So in this one here, you have to find the measure of an angle. The angle that you have to find is on the circle. Therefore, you know that that angle is going to equal half of the arc that it runs into. So knowing that, that means the angle is half the arc. So that means if I double the angle, it will equal the arc. So the arc here becomes 2 times 8x plus 18. And then I have how many degrees to get around? 360. So we get, I'm going to distribute out right away. I'm going to get 16x plus 36 plus 9x minus 2 plus 6x plus 16 equaling 360. Bless you. Bless you.
Combined like terms.
Correct. Combined to like terms. So you have 16 and 9 is 25. 25 and 6 then is 31. That takes care of all of my variables. And one of the things that I normally do when I have these big giant problems like this with all the extra algebra is that when I write it out, I cross off the ones that I've taken care of. That way I don't accidentally go back and double count them. Okay? Now I go to the numbers. 36 and 16 is 52. Subtract 2 and you get 50. From here, you should notice that it winds up being really easy math. Subtract 50, you get 310.
X equals to 10.
X is 10. But then it asks you to find the angle STR. So you take the value of X, 10, and you substitute back in. So I take this here, and what's 8 times 10?
80.
80 plus 18 is?
98.
There you are. Okay. Does that help, Ellie?
Yeah.
No.
Whiskey, enough with the opposite stuff, okay? It's getting old. Actually, it's not getting old. It is old.
It's ancient.
I didn't ask you. I didn't ask you.
This man's on a roll.
Okay. You understand? Yes, ma'am. Oh, sorry. I'm sorry. Miss Hannah, forgive me.
I wasn't watching, so I just had to talk to you.
What do you got?
Number 6.
All you do is suck each other.
It's actually a lot easier than you think. A lot easier than you think. In the instructions throughout all the problems here, we're saying if segments appear to be diameters, they are. So you know that those are diameters, which therefore means those are vertical angles. So 15x plus 7 has to equal 2 times the 7x plus 7s because the congruency thing works. So you have a 15x plus 7 is 14x plus 14. And you can probably see where this is headed right away. Subtract that 7, subtract the 14, x, and you're going to get x is 7. It did ask for angle DFC, which is just this part here.
49 plus 7, 56.
There you go. 49 and 7 is 56. Okay. Ms. Ross?
Like 7, 8, or 9, like, I tried skating.
Okay. They're all basically the exact same problem. And you're going to kick yourself. When you see a right angle and it creates a triangle,
Are you kicking somebody?
I'm not trying to, but, which means, what are you going to use to solve for x? That's it.
Okay, I wasn't sure, but do you like
That's it. Yes, sir. Yeah, Ross, all three of those are the exact same. How many degrees are in a circle? Okay. There's 360 in a circle, and that means this is 3 plus 13x. Obviously, this is your 25x. Just put them all together. Does that equal 360s? 21x minus 4 minus 2 plus 18x plus 3 plus 13x plus 25x plus 3 plus 13x is 360. You just got to be careful when you're putting all these together not to double count something, because that's usually what people screw up. 24, 18, 21 and 18, that gets me 39. 39 and 13 gets me to 52. 52 and 25 is 77. 77 and 13 then gets me to 90. All my x's are taken care of. 3 plus 3 is 6. Minus 4 minus 2 is 0. And substitute it. As long as you keep it straight and you don't double count something, you're going to be fine. Miss Maria, what do you got?
Number
9?
yeah.
Oh, as I was just saying with Ross, what happened? This is the exact same problem. The only thing that you have to remember is when you are perpendicular to a chord and it's a diameter, it bisects the chord. So if that's 10, that side's 10, and then use Pythagorean theorem. Mr. Lars.
Like 15.
Like 15 or 15. Arc length. Central angle over 360, 2 pi r. What's your central angle? The angle they're giving you is 300. 300 over 360 times 2 times pi times r. Well,
He's doing all that smart shortcut math. You could always just type it in your calculator.
I made the mistake of doing 360 or just doing like 60.
careful. When it shows this in a diagram like that, a lot of times they over darken it and they show the arrow. The arrow is telling you what the central angle is via the direction like that. Okay. So there it is.
See the Cubs comment.
Miss Hannah, last one, then we'll get going. Which one? When an inscribed angle hits a diameter, what's the angle?
Half of it.
Half the arc. Well, the arc that's created here is how much? 180, which makes M 90, which makes this angle here 50. If it's on the circle, it is half the arc. What's the arc LM? If the angle is half the arc. There's other ways to do this also. If you know that this is 180, this makes this 80, what's left over, you can go there as well. And you get 100 from subtracting out. It works the exact same way. Okay. Let's get finishing up with the last bit of the chapter. I think we've got through 10.3 yesterday. So we have 4, 5, 6, and 7. Okay. 4, 5, 6, and 7. There's so many parts. I always forget what to wait. So let's see. 4. I see what you did there. What's up? Yeah. So, since I don't memorize which sections are which, I'm just going to kind of use this one. Oh, inscribed angles. Well, we've been working with inscribed angles. That's not a big deal. 10-4 is your inscribed angles.
And polygons.
Your angle is equal to what? Half the arc. So your angle equals half the arc. That's where we got with 10-4. Now the other part in 10-4 talked about inscribed polygons. If you have an inscribed polygon, I'm sorry, inscribed quadrilateral, a quadrilateral can be inscribed in a polygon if and only if, or if opposite angles are supplementary. Okay. And then the rules of working through with angles and arcs still hold true, or the angle itself is going to be equal to half the arc that it runs into and whatnot. I believe that more often than not, when we did problems like this, we didn't really even have to use the opposite angles being supplementary. What we used quite often was just following out to the arcs and then setting things equal or adding things up to equaling 360. I don't think there was anything crazier than that, to be honest with you.
And what about if the inscribed angle hits the diameter?
It's gonna. We just did that right before we walked in. If the inscribed angle hits the diameter, what is it? Not vertical angles. What's the measure of the angle if it hits the diameter? If the sides hit the diameter? Well, that's the answer to the problem. But remember, if an angle is inscribed and it hits a diameter, what's the angle? Well, how many degrees are in a diameter? What diameter cuts into what? So what's the angle if it's 180? Thank you. Pay attention. It's early, apparently.
What do you do?
Whew. All right. All right. Then it got to the, well, I think it was a little bit crazier. Yeah, 10-4 was pretty easy. 10-4 was really quick. I don't think you guys really had much of an issue with that. Plus, it was kind of the same thing over and over again, kind of mixed in with some of the other inscribed stuff that we did. What's that? 10-5 had all the angle stuff. Outside, inside, This is where we dealt with angles if they they hit outside, inside, or on the circle. So there were three basic setups for this one. And we turned it into terminology, or we used terminology that made a lot more sense than anything else. Why go through the annoying way that they write stuff out instead of just making it user-friendly? For example, if your angle is formed outside the circle, your angle is equal to half the far minus the close arc. Okay, that was your outside. Excuse me. So you had outside angle. If the angle was formed on the outside, it was equal to half the far minus the close. If it was inside, remember what happens here. If the angle is on the inside, that angle actually hits two different arcs. Okay? The reason that it hits two different arcs is because whenever you have two lines that intersect each other, you get vertical angles. Remember that? When you have the vertical angles, those vertical angles are always congruent. So I know that if the angle is placed here, it's looking at that arc, and then via the vertical angle, it's looking at this arc. So what we did was the angle was then equal to half the sum of the two arcs. We did that. The angle is equal to half the arc plus arc. And then the last one was on the circle. And you've actually seen this one before because it follows the exact same rule as inscribed. Anytime that you have an angle that lands on a circle, it's equal to half the arc that it hits. No matter if it's inscribed or it just happens to be like a tangent segment. This angle runs into this arc. So the angle equals half the arc. So there was your outside, inside, on. And a lot of times with this stuff, it was just a matter of was it outside, inside, or on, and just we wrote things out. The biggest mistake that you guys usually made with these tended to roll with the outside stuff, especially if the far arc was written as a algebraic statement, and it had subtraction in there. And I believe I think I made sure there was one of those like that on this packet. We'll go through that very second. Actually, might as well look at that one real quick. I forget which one it was. Yeah, 27. Similar to what I'm thinking. If you look at 27. This is one of those outside angle on the outside, and it runs into two arcs, a close one and a far one. They labeled out for you the angle itself, the close arc, but they did not give you the far arc. You have to write that down. I know we ask a lot. So mesh, the arc here, 22x plus 9. So is this an outside, inside, or on angle? It's outside. Therefore, I'm going to write that the angle, 4x plus 8, is half. What's the far?
22x plus 9.
And what's the close? Notice how I put my close in parentheses because there's two parts to it. The reason that I needed to do that was because I have to distribute my negative to both pieces. If I don't do that, I'm going to be wrong. Plain and simple here. So I'm going to get, is it okay if I just double the other side right away to get rid of the fraction? You okay with that? So I'm going to get 8x plus 16. So I get 22x plus 9 minus 12x minus 9. And the 9's go away. And you get 22 minus 12. And now it's a very quick pick on the little guy. Pick on the little guy here, which one am I going to move? I'm going to move the 8x. Moving the 8x over, I'm going to get 16 is 2x, and x is 8. And then I believe it asks us to find that arc. Yes, sir? Because this is minus 1 here, you have to distribute the negative to both parts. Very common mistake. And then it's just a matter of substitute back in. Okay. That was the angle one. One of the ones that I think we forgot to talk about yesterday was and I just saw this as I was scrolling through the sheet here, was that common external tangent. You guys remember that? The common external tangent, I think this was in section 5. Exactly. The common external tangent meant that if you had segments, if you had two segments that had the same endpoint and they were tangent to the circle, those segments were always equal. That just meant that. So if you were tangent to a circle and you're starting from the same spot, it basically means that you created hypotenuse leg out of this, and that's why those things work, because the corresponding parts of congruent triangles are congruent. Okay. That's why that worked. So that common external tangent was the one where if you had a two segments coming from the outside of the circle and they hit the same spot, or they're tangent to the circle, that's what that meant. Does that make sense? I think this was one that I know you guys was pretty easy for you. And then the last chunk of stuff was what we just finished up working on, were your segments. Where your segment stuff, where you had segments that met on the outside, segments that met on the inside, segments that were tangent and through it. Okay. So when we're dealing with the segments, this is that whole thing where we just finished this. Where if the segments meet outside, that was your outside times the whole, equals outside times the whole. If they met inside, what do we write that as? How do we write that one out? Chunk times chunk is kind of the easiest way to write that out. Let's say this is A, B, C, and D. So we'd say A times B I do not see any addition in there, do you? Times, last time I checked, meant multiply. Just in case you forgot. There's your reminder. I know. It's a lot of information early in the morning. We'll do our best. And then the last one was where you had a tangent and that secant, where it was outside hole and a tangent part. So the last one of those was that tangent segment, was that outside times the whole. And we just finished up doing this the other day, so this should be, at least this last section should be the freshest in your brain. And that's where we got that. That tangent segment squared, that outside part, is just that where it touches it in one spot, square that, equals the outside chunk times the whole thing. Now be careful. The one part that you guys will mess up. If that's 4x, when you square that, what do you get? Try again. Try that again. Remember, it's 4x quantity squared, which means, technically, 4x times 4x, which is 16x squared. Don't forget that. That is something that shows up because it's algebra. Okay. Hey, are you trying to make fun of me? I sense the sarcasm. Okay. And then the very, very, very last thing in circles was the one part that we spent the least amount of time on because it took, 6 minutes. Equations. Now, I know that on that worksheet I had you guys write down equations of circles. We're figuring it out via the graph. There were a couple of them on there that you had to determine what the radius was given a point on the circle. I'm not doing any of that with you guys. Can you write the equation if I give you radius and ordered pairs? So the last one is the equation of a circle. And that was your that was the equation of the circle. Now remember, this was a lot easier than you guys are giving yourselves credit for here. If I have a center of a circle and it is at -2, 4, and I have a radius of 6, it is quite literally substituted in. Yeah, because when you sit there, your ordered pairs go HK. What comes first in the alphabet, H or K? Right. And it also goes horizontal, is left and right, which is your X. And K's go vertical, which are up and down, which are your Y's. It's the dumbest way in the world to remember that, but when you guys get to Algebra 2, you'll know why. You'll know why I was saying that. I'm just, it's like it's a premonition. It's a precursor. It is a. Thank you. I forgot what the word was. It's a prelude. It is the Easter egg hidden that tells you something that's going to happen later. We the people of the United States sort of form our units that should serve domestic tranquility and something. This is something along those lines. But at least I knew that part. 4th grade, yay! So my equation would be, what's minus a negative? Good. And you guys remember how I had you write this out when you had 6 squared? What did I just say to do at the end? Remember I just said just do this and call it a day? That's all you gotta do. You don't have to rewrite it. If you just, if you wanted to say 6 squared is 36 right away, that's fine. But
That's all we have to do.
yeah, that's it. Okay. We're not worried about all the rest of the conic values of these things because there's a lot of other stuff that we can do to them. We need to save something for Algebra 2 teachers to, make you cry about. I'm sorry, enlighten you further about.
And you might be lucky enough to have Mr. Murphy for Algebra 2.
No.
You and 39 of your other friends,
No.
it looks like. I'm serious. You guys need to know this stuff. You guys got to get involved with school board stuff. As you go through the last of these things, you'll see that the values that you have in here are pretty quick. There's not a lot of crazy. I'm sorry that the 2x and the 3 kind of got garbled in there, so. Is there a style problem that you can think of off the top of your head that you would like to double check?
Can you just go over the one where we like factor it out?
Sure.
Yeah, 'cause is that the number? Yeah.
Are you guys okay if I rewrite this bottom portion as x minus 4 instead of minus 4 plus x?
Okay.
Is that okay if I just cross it out and rewrite it as x minus 4? I'd rather do that because I think, to me, it just makes sense to me. It means the exact same thing. It's just how my brain is wired, which we all know is kind of weird, short-circuited. Something.
It's the truth.
So this is your outside hole equals outside hole. So when you write this out, just start with one part of it. Your outside is 6. The hole then would be 6 and 15, otherwise known as 21. That'll equal your outside, the x minus 4, times the whole thing, x minus 4 plus x, which gives you, when you add things, come on,
2x.
okay, so you get 2x minus 4. So, yes, this is the one style that you have to FOIL out to begin with. So we start with the 6 and 21. That's not bad. We get 126. FOIL out the right-hand side. You're going to get 2x squared for your first. Your outside is minus 4x. Your inside is minus 8x. And your last becomes a plus 16. Right away, I know that I have to combine my like terms, and I'm also going to set aside equal to 0. So I'm going to combine the negative 4 and negative 8, and then at the same time, I'm going to move over the 126. So I'm going to get 0 is 2x squared minus 12x. 16 minus the 126 gives me a minus 110. And now I have a factoring problem. But this factoring problem is actually, it looks daunting to begin with, but what's always your first rule of factoring? GCF, what do we have? 2. In this case here, when you have a factoring problem, you have a GCF, take the GCF out. That GCF, it plays a role of what we call a scalar. It's just a multiplier. It has no bearing upon the zeros, okay? The zeros will still be found normally. The scalar just goes away. So if I divide everything out by 2, I'm going to get x squared minus 6x minus, what is that, 55? And now you should probably see it pretty quickly. What times what is 55 that you add together, or excuse me, negative 55 that you add together to get negative 6? Well, yeah, your factors of 55 are 1 and 55 and 5 and 11. Okay? And you have to add to a negative 6, which means that's not going to work. And the 11 is the negative. So even though it seems like it's a larger number, there aren't that many factors of 55 to have to worry about. So you wind up then with a negative 11 and a positive 5 for your terms. So it's x minus 11 and x plus 5. Those terms, the things in parentheses, generate zeros. The zeros of this then become 11 and negative 5. Can I have a negative segment length? Nope. So I just cross off the negative 5 and go on my happy merry way. Okay. Finish those out, guys. Finish those out. They're great review problems. We'll get started tomorrow. I believe the test is like 14 questions, so it shouldn't be that that crazy at all. It's pretty quick. There's no I reviewed it again yesterday, made sure that it didn't have anything that would take too much brain power to go through, so. All right, yes, sir. 21? Sure. When you're tangent, what is created at the circle? What's that? When anytime a thing is tangent to a radius, what's created right there? A right angle. So just use Pythagorean theorem. Okay? Yeah, anytime, and that's the thing here, it says, assume lines that appear to be tangent are tangent. So if you're tangent to a circle, you're always perpendicular to a radius. Okay?
So it would be 11.4, like, squared plus
0.2 squared equals something squared. Yep.
so like the long one's always the
Across from, yes, that would be an important thing to
I know,
remember,
yeah, I
yes.
kind of
Yes, knowing which one's the hypotenuse is usually an important thing to do.